We will solve the following exercise. Exercise is the number 2.14. A surveyor determines that the horizontal distance from A to B is 400 meters, and the horizontal distance from A to C is 600 meters. Graphically determine the magnitude of the vector RBC and the angle alpha. Alright, so as I've been saying the previous videos, one recommendation from me to you is that it's to actually to use the image that the problem is given to you. Why is that? Because while I take my time to read you this shape, well, that is going to take me a little bit of time, and if I'm doing some tests, some evaluation, then that time is going to be needed maybe at the end or whatever. So my recommendation for you to save time is to use the image that the problem is given to you, right? Well, so the exercise is telling me that the horizontal distance from A to B is 400 meters. Okay, so I can see right here that the horizontal distance from A to B is 400. And it is also saying to me that the horizontal distance from A to C is equal to 600. Alright, they are telling me these two angles, and I have to find the magnitude of RBC, and so RBC is equal to what? And the angle alpha is equal to what? Alrighty then. So what I'm going to do first is that I'm going to say that this triangle has a specific magnitude. This triangle. So you can see right here that I have a triangle. Let me rewrite this information and this. So right here I have this, right here I have this, and right here I have 600. Right here I have this, and this is equal to 400. That means that this is equal to A to B and A to C. That's right. That means that this is equal to 200. Why is that? Because 600, that means that this magnitude minus this magnitude is going to be equal to this magnitude. Alright, so first I have this, and I'm going to start creating some different triangles. For example, right here. And I think that would be all. Why is that? Because I have right here one triangle, two triangles, one of the most important ones, that is this one, and that would be all. So they're telling me to find this magnitude. So what I can do is to find this magnitude. Alright, when I find this magnitude and this magnitude, I'm going to be able to find this one. Alright, once I have this one, I can find RBC and the angle alpha. Alright, so I'm gonna start creating the triangle that I just set, this one. And that triangle will look like this, something like this. Alright, right here I have an angle of 60 minus 20. That means I have an angle of 40. No, my mistake. No, this is equal to 60 degrees. Yeah, sorry. 60, and right here I have a cathedus equal to 400. Alright, as you can see right here, I have this triangle. This is an angle of 60 and a cathedus of 400. Alright, then I have to look for the other cathedus. So what I can do is to use, for example, I don't know if I have to use the sign of the cosine, where right here I have the adjacent cathedus, but I need the opposite cathedus. So what I have to do, for example, is to say that right here I have an angle of 90 degrees, right? That means that, and this is a rule, this angle that I'm going to call, for example, beta, is going to be determined. How am I going to do that? Well, the symmetry of the angles within a triangle must be equal to 180 degrees. That means that 60 plus 90 plus beta is equal to 180. That means that beta is equal to 180 minus 60 minus 90. Alright, that means that beta is equal to 180 minus 150. That means that beta is equal to 30 degrees. Alright, so I have this part. What I'm going to do is to create a sines law. So if you don't know how to create a sines law, you just have to take into account the cathedus and the opposite angle. Alright, and you just have to create an equivalence. So 400 divided by the sine of beta is going to be equal to the cathedus that I require, that I'm going to call it, for example, x divided by the sine of 60. Right, as you can see, I have the magnitude and the opposite angle, the magnitude and the opposite angle. Right here and right here, the opposite angle. Alright, so I have the magnitude of beta. That means that I can find x. X is equal to 400 divided by the sine of 30 multiplied by the sine of 60. Right, x is equal to, let me use the calculator right here. So 400 divided by the sine of 30, I have to make sure that I'm using degrees right here in the calculator, and this is multiplied by the sine of 60. Right, x is equal to 692.8203. I always use 4 significant digits after the comma. Well, I'm going to storage this value within the calculator, within the memory of the calculator. So I just have to press Shift, Storage button, and select one of the letters in red. In this case, I'm going to select A. Right, so when I look for the letter A, it is going to tell me the value that I just got. Okay, this is equal to 692 meters. Alright, then I'm going to use this second triangle for me to find this cathedus. Alright, so bear with me while I create the triangle. Right here, this is equal to 20 and this is equal to 600. I'm going to do the same thing. I'm going to look for this angle that I'm going to call, for example, theta. And right here I have an angle of 90 degrees. That means that theta is equal to 180 minus 90 minus 20. Theta is equal to 70 degrees. That's right. And I'm going to create the sine's law. That means that 600 divided by the sine of theta is going to be equal to, I'm going to call this cathedros y divided by the sine of 20. That means that y is equal to 600 divided by the sine of theta multiplied by the sine of 20. Alright, y is equal to 600 divided by sine of theta, that is equal to 70 multiplied by the sine of 20. Okay, y is equal to 218.3821 meters. Alright, so once I have these two values, I'm going to be able to find these cathedros that I'm going to call, for example, h, whatever. That means that h is going to be equal to x minus y. So I'm going to search this value in the calculator, search, and I'm going to select b. Right, so when I look for this value, it is going to provide me that information. That means that a minus b is going to be equal to 474.4381 meters. Alright, and we have the triangle that we need. So right here I have the triangle, the important one. Sorry. This looks something like this. Right here I have an angle of 90 degrees. Right here I have a value of 474.4381, and right here I have a value of 200, and I need this angle. Alright, so for me to, what I'm going to do first is to find the value that they are asking to me, RBC. And as you can see, what I'm going to use is the Pythagoras theorem. That means that RBC is going to be equal to the square root of 474.4381 square plus 200 square, and that would be all. RBC is equal to, I'm going to storage this value. So storage, and I'm going to say that it's going to be equal to C. Alright, so when I look for C, it is right there. Alright, so the square root of C squared, a square plus 200 square, 514.8704 meters, and that is our first answer. Well, the second thing that I have to look for is the angle, and for me to do this I can use either cosine or sine. So I'm gonna use, for example, this value, because this value does not contain any decimal numbers, and I'm going to use the hypotenuse. Alright, so the cosine of the angle alpha is going to be equal to the adjacent cathedros, in this case 200, divided by the hypotenuse, that in this case is equal to 514.8704. Right? That means that the angle is going to be equal to the cosine evaluated to the -1 power of the same value. Alright, so alpha is equal to, right here I have this value. I'm going to search, for example, in D. So when I look for D, everything looks correct. That means that, sorry, the cosine related to the minus one power of 200 divided by D. $67.1420808. And this is degrees. Alright, guys. There is one way in which we can check that these answers are correct, and the way for me to do that is by using a software. In this case, I'm going to use CATIA V5. Remember that you have within the channel some different tutorials of this tool for you to learn how to use it, right? So what I have to do is to create this shape, well, the shape of the exercise. So I'm gonna start using the lines of the software for me to start creating this, right? So right here I have this triangle that is pretty important, and I want to create this second triangle. All right, so right here I have 400 with respect of this point, but don't worry, I know that right there I have 56. Okay, this doesn't, I don't like it. Right here I have that, this, and the angles, two angles. I want to make sure that I'm using the same measures or dimensions that the exercise is providing for me. So yep, that would be all. So this is equal to 600. Don't worry. This is equal to 400. Don't worry. This is equal to 20. And this is equal to 60. Alright. So this does not look anything like the exercise. But remember that these exercises are meant to be like more like to be shown the figure, but now the real dimensions, right? So as you can see right here, I have the point A, B, and C, and you're asking me to find this angle with respect of this line, the angle alpha, and the magnitude of RBC, right? So I just have to click right here and measure this. So right here I have the 514.87, and right here I have the same value, and the same goes for this angle reference, 67.142 degrees. Right, as you can see right there, I have these two same values. So that would be all, guys. This is how you can solve this exercise and check the information.